Now this next problem is truly an awesome problem. Show that the volume of a sphere of radius r is 4/3 pi r cubed. Think about how to do this first. You're going to be asked to do a similar problem where you're going to derive the formula for the volume of a cone of radius r and height h. So the hardest part of this problem is to discern how we're going to do it. And you need to think about it first, and you think about, well, how would I construct a sphere as a solid of revolution? And the answer is, well, I guess if I took a semicircle and rotated that about the x-axis, that should be adequate. So the solid sphere is formed by rotating a semicircle about an axis. So let's find the equation of the upper semicircle. If the circle is radius r, and of course that would be x squared plus y squared equals r squared. Any good pre-calculus student knows how to find the equation of a circle with radius r and center at the origin. Solving for y leaves us with y equals, actually technically this should be plus or minus square root of r squared minus x squared, but we're just going to rotate the upper semicircle. And so there is this upper semicircle. And so here's that upper semicircle rotated. Hope you can see that it made the sphere. I guess I should have made the sphere a little bit more obvious. Pardon me if I, on the fly, made it a little more obvious it was a sphere, and you can't see that dotted line. It's on the other side of it. So, if we subdivide, you can see that we've got a disk. It's making up part of that sphere. So the volume would be pi times from negative r to r times the radius of that disk, which is square root of r squared minus x squared squared, which is kind of nice because we get rid of the radical that way, times the thickness of the disk dx. So integrating r squared minus x squared, we just get, remember r is a constant, so we just get r squared times x minus x cubed over 3. Of course, times pi, and evaluate that at r, and subtract that evaluated at negative r. We wind up with pi times r cubed minus r cubed over 3, and then minus negative r cubed plus r cubed over 3. So we wind up with this r cubed plus this r cubed, that's 2r cubed, minus r cubed over 3 minus this r cubed over 3, so minus 2r cubed over 3. 2 is 6 over 3, 6 over 3 minus 2 over 3 is 4 over 3, so we wind up with 4/3 pi r cubed, which is exactly what we wanted to show. Interesting to note, this formula was first discovered in mathematics by Archimedes, probably one of the great geniuses, if not the great genius of mathematics, who was able to discover this formula using a method he called the method of exhaustion, which was essentially adding up an infinite number of infinitely thin slices. So Archimedes pretty much had this idea down practically 2,000 years, actually about 1,900 years before Isaac Newton and Wilhelm Gottfried Leibniz figured it out. So pretty impressive. And also maybe pretty impressive that we just did that as a simple example in our Calculus II class.